get some really good material to help you to get ready for this midterm. Like it's all I've been doing for a week, just refining and refining. So I'm telling you right now, this is going to be on your midterm, okay? So just make yourself focus, okay? Okay, so we are going to deal with radicals today, okay? And a little bit with fractional exponents. What is a radical? Everybody in the room talk to me. What is that? Do you know? Let me tell you. It's a square root, okay? So everybody right now, put a square root under that word radical, and that's what a radical is. It is a square root, okay? So my pen keeps being weird, just so you guys know. It's not working right now for a second, so I have to use my finger. So it's going to be messy, just so you guys know. Okay, so simplify the square root of 40, okay? Well, everybody grab your calculator right now, okay? And I want you to go second, and then I want you to go down like 5 buttons and hit that x squared. And then I want you to put in a 40 and hit enter. Is the square root of 40 a nice number, like 10 or 6 or 14? No. So it doesn't simplify nicely, okay? So here's what we have to do. You're going to write that 40 down, and I call this break it down. So you're going to break this 40 down into prime numbers. If 2 goes into the number, I always do 2. So this is going to be 2 times 20. And then 20 is 2 times 10. And then 10 is 2 times 5. So inside of there, you guys, you have 2 times 2 times 2 times 5. Grab your calculator right now for me and punch in 2 times 2 times 2 times 5 and then hit equals. What do you get? You get 40, right? So this statement right here and this statement right there are equivalent. They're the same thing. I just broke it down, okay? Okay, see those numbers inside of there, 2, 2, 2, 5? They don't want to be in the square root. It's like they're in jail. They want to get out. And the only way they can get out is if there's 2 of them. So these 2 2's right here, guys, are super lucky because they get to come out. But when they come out as 1. So on the outside, you're going to have 1, 2. And on the inside, you're going to have a 2 and a 5 that are multiplied together, which gives you a 10. And that's your answer. And that's it. Okay? 169. Everybody grab your calculator and hit second x squared. And then put in 169. Hit enter. And what do you get? 13. So it's a nice number. So you literally can just do that right on your calculator and you're done. And if you didn't take the time to do that on your calculator, it would have been kind of a pain to do. So I always kind of start, at least look at it and say, is it nice? Hey guys, if your phones are not in your phone boxes, will you please do that, okay? Put them in and turn them upside down. Okay, 54. Do you know off the top of your head if the square root of 54 is a nice number? What do you think it is? Do you think it is? 7 squared is 49. 8 squared is 64. I skipped 54. So it's not nice. No. Okay, so everybody write down the 54. And let's break this down. Okay, so 54 is 2 times 27. Now the 2 is done, but I need to break down the 27. 2 does not go into 27, but 3 does. So this will be 3 times 9. And 9 is 3 times 3. Now, don't write this down for me, but just look. 2 times 3 times 3 times 3. I'm not going to make you write that step. I'm going to let you simplify from the tree. So watch me do it from the radical and then watch me do it from the 3. So these 2 3's are lucky. They get to come out as a single 3. And inside, I have 2 times 3 is 6. Now I'm going to do the same thing over here. These 2 3's come out as a single 3. And these guys right here are stuck inside. 2 times 3 is 6. Oh, I didn't do my x's and all that business. Goodness. So that's the number part of it. Okay. Who says I understand what you did right there? Okay, great. So let's do this. On the outside, I have a 3. Then I'm going to leave some room. And on the inside, I have a 6. Okay. This is pretty important to understand, okay? This next minute and a half that I tell you is important, so listen really carefully, okay? See the x to the third, guys? That is x times x times x, right? So these two x's are lucky. They get to come out as 1, and this poor guy right here is stuck inside, okay? See the y? There's not even enough y's to bring them out, so it's just going to stay there, okay? Look at the z's, okay? Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is silly. I'm writing them out. These two come out as 1. 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 So all 12 of them come out. When they come out as, tell me, 6 of them. Yeah, because there were 6 pairs. That's your answer, and you're done. Okay? Now, I know that you don't want to do that. Okay, so, sorry, I'm having a little bit of issues. So this is a 3, and it's a z to the 6th. Okay. I know you don't want to do that, so I'm going to show you a trick. Everybody look right here. There's no trick with the numbers. You have to break them down. Look at the x's, okay? Watch this trick. It's going to save you. If there's no number in this little crevice right there, what's the number? It's a 2. So look what you do. You go 3 divided by 2. What's 3 divided by 2? 1. So you have 1 x out here. But does 2 go into 3 perfectly? No. You have remainders. The remainders stay on the inside. The y's stay the way they are. Look at the z's. 12 divided by 2 is 6 perfectly, so I have no remainders. That's my answer. Who says got it? Let me see. Great. Okay, now we have a cubed root. It's not any more difficult, you guys. It's just a different number. So everybody write down the 12. 12 is 2 times 6. 6 is 2 times 3. So guys, 2 times 2 times 3 is 12. But I have to now have 3 of the same thing for them to get out. And I don't have 3 of the same thing. So this is going to be a cube root of 12. But I do have a's and b's. So look at the a's. Look at the exponent. 3 goes into 3 one time perfectly. No remainders left over inside. Look at the b's. I don't even have enough to bring them out. So it's going to be b to the 2nd like that. And I'm done. Who says I gotcha? Let me see. Yay. All right. Here is question 2. Now what we're going to do is we're going to start adding roots. Okay? Everybody write this down up above. Write the square root of 2 plus the square root of 3. You guys, if I'm trying to add roots and the inside numbers are different, can I do that? No. I want you to write underneath x plus y. They're 2 different things. Can I add x and y together? No. Can I add the square root of 2 to the square root of 3? No. So this is not possible. I cannot add those things together. Okay? So everybody look at question 2. Look. Here's a term, and here's a term. This guy right here has a square root of 3, and this guy has a square root of 3. This guy at the end, he's different. So I can't add it together. But when I add those together, it's going to have a square root of 3. And then in front, 4 plus 2 is 6, like that. And then the 2 square root of 2 just comes behind, and that's it. Like literally, that's your answer. You guys look forward for a second. Let me show you something. When you see this, look what I want your brain to see. I try to train your brain. I try to train you to see it properly, and then it makes it so much easier. Look at this right here. This right here is like 2x. This guy right here is like plus 4x. And then this guy right here would be minus 2, tell me, y. So I can add those together, and I get a 6x. It wasn't an x, it was a square root of 3. This is a negative 2 times y. It wasn't y, it's really square root of 2. But it works the same as something you already know how to do. Who says I understand that? Let me see. Yay. Okay, look right here. You have to see that you have 3 terms. Look, term, term, term. 3 terms. The first guy has a square root of 5. The last guy has a square root of 5. So I can combine those and I get a square root of 5. The square root of 5 is not changing. That's like the x or whatever. In the front, I have a -1 and a +3. That's a +2. And then this 2 squared of 7 is all alone. You write it down and you're done. Yes, honey? Does not matter. You know why, honey? Look at this. If you have 1 plus 2, is that the same as 2 plus 1? Yeah. So it doesn't matter. I'm just adding things. Okay? Okay, good. So far, so good. Okay, here is C. Now, everybody stop. Can I add those together right now? No. But can anybody see anything that I can do? What can I do? You can simplify them, yes. Everybody write down the 28, and let's break that down. So 28 is 2 times 14. 14 is 2 times 7. See these two 2's right here, guys? They're going to come out as a single 2. So the square root of 28 reduces to 2 square root of 7. Let's do the 63. So 63 breaks down into 3 times 21. 21 breaks down into 3 times 7. These two 3's will come out as a single 3. So I have -3 square root of 7. Can I add them now? Yes or no? Yes. So it's going to have a square root of 7, and 2 minus 3 is a -1. There's my answer, and I'm done. Let me tell you one thing somebody has said. Well, several people have said to me before. Listen. Now that I know that this is 2 square root of 7, I need to turn this in to something that also has a square root of 7. No, they don't have to be the same. Your goal is not to get them the same. Your goal is to simplify and then see if they're the same. Who says I get that? Raise your hand. Okay, good. So don't worry about making them be the same. Okay, everybody look at question D. Talk to me about the square root of 121. What is that, everybody? What is it? It's 11. Good. Okay, so the square root of 121 is 11. Talk to me about the 32. Is that going to be a nice number? Like if I hit the square root of 32, am I going to get like an 8 or a 4 or something like that? Talk to me, guys. No. So what do? Break it down. Break it down is exactly right. Okay. So now I'm going to write down my 32. Sorry, I have to use my finger again. So I'm going to write down my 32. And 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4. And 4 is 2 times 2. Do I have to start with a 2? No, you don't. You do whatever you want, but I always start with 2 because I think it's easier. So these two 2's come out as a single 2. And these two 2's come out as a single 2. So out there I have a 4 and a 2 and a 2, right? What do I do to those numbers? 4, 2, and 2. Do I add them? Do I multiply them? What do I do? Come on, guys. You multiply. Yes. So it's a -16 times the square root of what didn't come out, that poor 2 down there at the bottom. So it's a square root of 2. So guys, look. Here's a term. Here's a term. You can't add those together. So there's nothing more I can do. So there's your answer. Okay? Yes. Ask your question again. Say it really loud, honey. Use a big voice. I literally can't hear very well girls' voices.
On the 16, could you just reduce it to 4 and 4 and then take the 4 and put it in front of it?
No. So the goal is not to simplify this guy. The goal is to simplify this guy. So once you pull a whole bunch of things out, do you see how I pulled this and this and this? I multiply those 3 things together and get a 16, and then I'm done. Did I answer your question?
I'm talking about the 32.
Okay, so let's talk about the 32. Okay. Go ahead, talk to me.
So 32, and then you put down the 2 and 16, correct?
2 and 16.
And then on the 16, it's just 4 and 4.
Sure, so 4 and 4. Okay, so yes,
Okay.
they don't have to be prime. So I have a pair, and that's all I care. So those 4's come out. 4 times 4 is 16. I understand. Yes. Thank you, honey. Yes.
Could you do 11 minus 16 and have that be -5 and then square root?
No. Look right here, honey. Term. This is like an x, and this is like a minus 16y. They're not like terms because that 11 does not have a square root of 2. You good? Okay, you guys are so awesome. Like, I don't ever want you to be inhibited in this class, and you girls just ask like amazing questions, and now you're going to get that right on the quiz. So I'm so glad that you're so confident, you know, that you would ask that question, and you guys are awesome. Okay, here's question E. Okay, so kind of ugly, but we can do it. Let's simplify this guy, okay? The numbers on this guy are not changing. I can't pull out any 2's, so it's just going to stay 3 outside, 2 inside. Look at the x's. 2 goes into 4 2 times, so that leaves you 2 x's out there, and I don't have any remainder x's hanging out in the center. Then look at the y's. 3 divided by 2 is 1, so I have 1 y, but it didn't go perfectly, so I have a y sitting there inside. Okay? Who says I understand that? I got to see how we're doing with that. Okay, great. Let's do this one. The numbers aren't changing. And if you look at the inside, guys, these 2 x's can come out as 1 more x. So then I would have x times x, which is x to the, what do I put there? Second. I add those. Yep. Y. And then I have a square root of y. Okay, this is important, so I want you to look. In order to add these, all of these variables plus the root must be completely, perfectly the same. Are they completely, perfectly the same? Yes or no? No. So can I add those together? No, I can't. Why are they not perfectly the same? Because the second guy, that's weird. That 6 should not be there. That second guy has, this first guy has a 2, and the second guy does not have a 2. Okay? Sorry, that first thing got kind of messed up. Okay, let's look at question F. Same thing. Simplify this, simplify this. Take your 12, break it down. So 12 is 2 times 6, 6 is 2 times 3. These 2 2's come out as a single 2. So you have a -2, and inside you have a 3. Notice I didn't do any variables. All I've done is just the numbers. Then see these 2 x's, guys? Those 4 x's, I mean? They're going to come out as 2. So I'm going to have an x to the second out there. And then see this y on the inside? I don't have enough y's for them to come out. So they're just going to stay the same. I'll have a y on the outside and a y on the inside. Okay, let's do the next one. The 27 is going to break down. So it's going to be 3 times 9. And 9 is 3 times 3. So these 2 3's come out. So I'm going to have a plus 3. The 3 sitting there stays inside. The only x's on the whole problem are on the outside, so I'm going to write that down. Now look at the y's. 2 goes into 3 1 time, but not perfectly, so you have a remainder. So I'm just simplifying, okay? Now let's see if I can add these. X squared y, square root of 3y, square root of 3y. I can totally add these together. In your brain, when you see that, you see -2x plus 3x. That's what you see. Or -2a plus 3a, something like that. So the variables are going to stay the same, guys. X to the second y times the square root of 3y. And then in the front, -2 and a plus 3 gives me a plus 1. That's my answer, and I'm done. So none of those variables change. None of the things that have to be the same change. It's just the number in front. Who says I gotcha? Let me see. Yes, sir.
Isn't it a negative y at the start of the
So let me say it like this. Are you going to answer him, Paige?
No, that's what I thought.
Okay, so look right here. This is -2a, right?
Yeah.
plus 3a. What does that give you? 1a. What's your a? All that business right there. So that's it. Did I do something wrong?
It's just the negative y
Yeah, at the beginning of
at the very beginning.
It's a negative right there. So the negative I wrote here, the y stayed there, the 12 simplified, so it's still a negative, so then a -2 and a +3 gives me a +1. Are we okay?
Yeah.
Paige, okay, honey?
Yeah.
You sure? Okay. All right, let's keep going. Okay, can this be simplified? Basically, what they're saying is, can you add those together? What would be required in order for them to be simplified? Okay, can it be simplified? I don't know. What would be required to do so? I'm going to say the numbers inside of the 6th root finish. In order to add those, the numbers inside, talk to me everybody, must be the same. Perfect. That's exactly what I was going to say. Must be the same. In order to answer the question, can it be simplified? We would have to break that down. So I'm not even going to do that. So we're kind of just changing the problem to what would be required in order to add those two things together. Okay, that's all I'm going to do. That's enough. Okay. All right. So this one right here. So this is really strange that that's a G. I bet that, does yours say a G or does yours have a dot? A dot. Perfect. So when it translates over, it kind of gets a little weird. So anyway, all you're doing is multiplying. Look how simple this is. You go, this is on the outside, this is on the outside. Multiply those together, you get a 10. The 2 is on the inside, the 3 is on the inside. Multiply them together, you get a 6. It stays on the inside. That's your answer. That's all you do. Yes, honey?
So when you're multiplying, you can combine it and you do one with I and you can't.
Say it really loud.
I'm sorry. When you're multiplying, you can combine the thing to do one with I and you can't.
Correct. Did you hear her? I'm glad you guys did. No, it's my fault. It's my fault, honey. She says, so when you're multiplying, you can do that. You can combine them, but when you're adding, you cannot. And that is perfectly right. Good, good summary. Okay, here we go. So 3 squared to 10 times 2 squared to 5. 3 times 2 is 6. Square root of 10 times 5 is 50. Then lots and lots of people say, done. Are we done? Why not? The 50 will break down, right? So everybody write down your 50. And that is 2 times 25. And 25 is 5 times 5. So these two 5s come out as a single 5. And join the 6 that is there already. So on the outside, you have 5 times 6, which is a 30. On the inside, you have a 2, and you're done. Who says, I feel good about this lesson? I don't think this is difficult. Okay, good. That makes me feel happy. Okay, this one right here. A little different. Okay, look. This is actually a pretty important example. It's going to save you time and grief, if you can understand this. Outside, 5 times 2 is 10. The square root of 6 times the square root of 6 is the square root of 36, right? 6 times 6 is 36. Am I done? What's the square root of 36? 6. So this is just 10 times 6, which is 60. Look what I want you to be able to do. I want you to be able to do that without doing that middle step. So I want you to go, 5 times 2 is 10. The square root of 6 times the square root of 6 is 6. The square root of 10 times the square root of 10 is 10. The square root of 40 times the square root of 40 is 40. So if you're multiplying the same exact things, it's that number with no square root. Who says I understand that? Raise your hand. Okay, I'm telling you, if you can remember that It's going to save you a lot of time and a lot of grief. Okay? Okay, here we go with question D. Everybody freeze right there. Pretty sure we've talked about this in this class. I get my 1010 and my 1050 mixed up. 10 minus 4th root of 4, 10 plus the 4th root of 4. This and this have a word that that describes the relationship between these things. This right here and this. What's the word? Do you remember the word? It is a conjugate, yes. Okay, everybody write down the word conjugate. Sorry, I'm really having pen issues today. So write down the word conjugate. C-O-N-G-U-G-G-U-J. C-O-N-G-U-J-U-G. Okay, let's do J-U-G. C-O-N-J-U-G-A-T-E. They're conjugates. Okay, good. If you're multiplying conjugates, write down the word FOIL. We did talk about this, right? You don't have to FOIL. Out of those letters, F-O-I-N-L, which ones do you not have to do? Do you remember? We've done this. O and I. Why don't you have to do O and I? Because they'll cancel out. You're exactly right. So look what we do. You go 10 times 10. That's F. 10 times 10 is 100. Then all you have to do now, guys, is last. Look. Positive, those purples. So positive times a negative is a negative. Then you have the 4th root of 4 times 4, which is the 4th root of, tell me that. What number goes inside? The 4th root of 4 times the 4th root of 4 is the 4th root of, tell me, 16. You multiply the numbers. We just did that. Okay, 16. Okay, do you think we're done? What do you think? What do we do? Break down your 16. Yep, everybody write down 16. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. I have to have 4 of the same number to pull them out, and that's exactly what I do have, 4 of them. So this is 100 minus 2, which is 98, and we're done. I'm going to show you how to get the 4th root on your calculator. Okay, everybody grab your calculator. Punch in a 4. You're going to want to pay attention. Then hit the second button at the top. And then go down 1, 2, 3, 4 buttons to that caret button. Go to this button. Okay, hit that. Then put in 16. Then hit enter. There's your 2. So that's how you put in the 4th root, or the 5th root. You'd go 5, second, hit that button. Okay. Okay, some of you made me nervous. A lot of you made me nervous. Look right here. You didn't know the answer to this. The square root of 2 multiplied by the square root of 3 is the square root of, tell me, 6. Even if it's 4th root, who cares? So the 4th root of 2 times the 4th root of 3 is the 4th root of, tell me, 6. So you guys couldn't tell me what the 4th root of 4 times the 4th root of 4 was. Well, it's a 4th root, and then you just go 4 times 4 is 16. Same rule. Okay? Okay, question E. Everybody look at it. If you take the first step wrong, you're going to miss it. What's the first step? Write it twice. Yes. So it's 5 minus the square root of 2 times 5 minus the square root of 2. Are these conjugates? Tell me that. No. So we have to FOIL. Everybody write down the word FOIL. F stands for first. That's this. 5 times 5. 5 times 5 is 25. Outside is this. 5 times a negative square root of 2. The 5 is on the outside. Square root of 2 is on the inside. It's going to stay that way. So it's just minus 5 square root of 2. Inside is this. Guys, look. Negative square root of 2 times 5. The 5 is on the outside. The 2 is on the inside. It's going to stay that way. Okay, I want to see who can answer this question here. Now I'm doing this, guys, look. Negative square root of 2 times positive. Negative square root of 2 times negative square root of 2. Negative times a negative is a positive. Every person in the room, what's the square root of 2 times the square root of 2? It's not 4. It is not 4. It's the square root of 4. And what's the square root of 4? 2. So that is a 2. Okay? Now look at this. 4 terms. 1, 2, 3, 4. 25 plus 2 is 27. Negative 5 square root of 2. Negative 5 square root of 2. That's a negative 10 square root of 2. And I'm done. In any order. Okay? Okay, everybody stand up for a second. Stand up. Stand, stand, stand. Yes. I can't hear you. You okay? Okay, stand up and stretch. Stand up and stretch. Okay, while you stretch, everybody's up, everybody's moving. I want your bodies moving. I'm gonna quiz you. Everybody in the room, what is the square root of 5 times the square root of 5? Tell me. You're all wrong. 5. The square root of 5 times the square root of 5 is what? 5. What is the square root of 7 times the square root of 7? 7. What's the square root of 10 times the square root of 10? What's the square root of 16 times the square root of 16? What's the square root of 1,000 times the square root of 1,000? What's the square root of 1,000,000? You're supposed to be moving. Times the square root of 1,000,000. What's that? Tell me. What's the square root of 2a times the square root of 2a? 2a. You got to get that in your brain. Okay? Okay, take a seat. All right. Halfway done. All right. Ugly. Ugly, ugly. One word that tells me the first step we're going to do. What's the word? Distribute. Yes. So it's this times this. So that is the cube root of 75 times 5 is 375. So the cube root of 375, y. Yes?
Could it be easier if you said 5 to 75?
Yes, and I was going to, but I think if I would have confused people. So I'll tell you what she's saying in a second. For now, let's just keep going, okay? Positive times a negative is a negative. The cube root of 5 times 2 is 10. And then this guy right here, just write him down. This parenthesis right there, see that parenthesis right there? Cross that out. Shouldn't be there. Okay, let's break down 375. Well, I know 375 is 5 times 75. I know that right now. 75 is 5 times, what is that? 15? I think? Yeah, thank you. And then 15 is 3 times 5. This is a cubed root. So look, 1 5, 2 5s, 3 5s. So those 3 5s come out as a single 5. It's a cubed root. This poor 3 right here is stuck inside, and the y is also stuck inside. The cube root of 10 does not simplify because 10 breaks down into 2 times 5. I don't have any cubes. Let's break down 27. So 27 is 3 times 9. 9 is 3 times 3. So these 3 3's come out as a single 3 like that. So the 27 is completely gone. So on the outside you have a 6, and on the inside you have the cube root, and then you've got a y. Okay, look right here. Cube root of 3y, cube root of 10, cube root of y. Your brain sees this. 5x minus y plus 6 what? Z. Yep. They're all different. I can't do anything. I can't add any of those things together. That's my answer, and I'm done. Who says, I still feel good about this lesson? I still feel like I understand. Okay, great. All right. Rationalizing denominators. This is going to be on your midterm. Rationalizing the denominator means, someone tell me what it means. You tell me. Do you remember? Get rid of, tell me. Yep. Square root on the bottom. Get rid of the square root on the bottom. Okay? Okay, let's look at A. What's on the bottom that can't be? Square root of 2. So I'm going to multiply top and bottom by the square root of 2. Then on the top, I have the square root of 3 times 2 is 6. Everybody in the room, you better know this answer. What's the square root of 2 times the square root of 2? 2. Can I reduce the 2 and the 6 right there? Can I reduce those? No. Why not? One's in, one's out. The 2 is outside of the square root. The 6 is inside of the square root. That's all you can do. Okay, let's do the next one. This is wrong. Well, this is unnecessary. Look. I would never do that. It makes it more difficult. Someone tell me what's wrong with what I did. Go ahead. Okay, what's wrong with that? Why don't I have to do that? But why not the 4? Why the square root of 5 and not the 4? Say it. Someone just said it. It's not in the square root. So I don't care about the 4. The 4's not a problem. The problem is the square root of 5. So all I have to do is multiply top and bottom by the square root of 5. Don't do the 4. You don't need to do the 4. Thank you, you two. Okay? On the top, you have a 3 on the outside. And on the inside, 3 times 5 is 15. The bottom's getting a little complicated. Look, on the outside, you have a 4. Everybody in the room, what is the square root of 5 times the square root of 5? 5. So do I put 4 plus 5? Is that what I do? What is it? 4 times 5. So your answer is 3 square root of 15 all over 20. Can I reduce the 15 and the 20? Yes or no? No. Why not? One's in, one's out. Everybody in the room say that. One's in, one's out. One's in, one's out. Okay, look at the next one. C we're not doing, right? Is that the one we got rid of? Okay, let's go to D. Everybody look at that. You could do this. Everybody stop right here. You could do this. But you're making it tougher. That would be tougher, in my opinion. Instead of doing that, can anybody see anything else we could do? Go ahead. Break that 12 down, right? Break that root down. So everybody go 12. 12 is 2 times 6. And 6 is 2 times 3. So these two 2's right here come out as a single 2. So I have 3z to the second. On the bottom, I have a 2. And on the inside, I have a 3. Look at the z's. 2 goes into 3 one time with 1 left over, and I have a b. I'm still not going to multiply by the root yet. I'm still not going to do it. Can anybody see why? What else can I do? Look right here. Can I cancel those? They're both out, right? So this is 3z over 2 times the square root of 3zb. Now I'm going to do it. So I'm going to simplify it. Everything that I can do and then get rid of it. So multiply by the square root of 3zb, both the top and the bottom. So on the top, you have 3z times the square root of 3zb. Watch the bottom. Be careful. On the outside, you have a 2. Every person in this room better know the answer. What is the square root of 3zb times the square root of 3zb? 3zb. And what do I do to the 3zb and the 2? What do? Do I add those or do I multiply those? You multiply those. So everybody go 3zb. But now look. You've got a 3 on the top and a 3 on the bottom. Cancel those out. You have a z on the top and a z on the bottom. Cancel those out. So now your answer is the square root of 3zb over 2b, and you're done. Can I cancel the b's? Everybody in the room, can I cancel them? Why not? All of you. I made you say it a second ago. Why not? One's in, one's out. Okay. Here we go. Should I do this? If I do, I'm not wrong. Should I do that? Talk to me, guys. I'm not going to. I'm going to simplify. So I'm going to take out an x. So I'm going to go 3x over 6. 2 goes into 3 one time, and that leaves you 1x left over inside. But now I can do something else. Look, x on the outside, x on the outside. 3 goes into 3 once, 3 goes into 6 two times. It's so much easier now. It's 1 over 2 times the square root of x. Now I'm going to multiply top and bottom by the square root of x. So my final answer is the square root of x over 2. Everybody in the room, what's the square root of x times the square root of x? X. That's your answer. Who says, I still understand this? I still feel good. Okay, good. All right. Question F. Looks weird. This one's difficult. I remember the last 2 years, this is only the 3rd time we've taught this course. This problem blew people's minds. Okay, watch. Write this as the 4th root of 5x over the 4th root of z. So separate it. It is not correct to multiply top and bottom by the 4th root of z and to say that that gives you a z on the bottom. That's false. Can anybody tell me why that's false? You're exactly right. You need 4 of them. And how many do I have right now, honey? 2. So if I only have 1, everybody listen, if I only have 1 and I need 4 because it's a 4th root, I have to multiply by the 4th root of, talk to me. If I have 1 and I need 4, everybody, how many am I missing? 3. So it has to be the 4th root of z to the 3rd. Look why. Just look right here. Because then the bottom is the 4th root. You've got that z, and then these 3, z, z, z. These 4 z's come out and become a single z. So you have to have 4 of them. If I only did this, guys, look. I wouldn't have 4. I'd have z and z, and I'd have 2. I need 4. So this has to be 3 right here, and this has to be 3. Who says, I understand you? Raise your hand. Let me see how we're doing. Okay, good. So the bottom's a z. The top is the 4th root of 5x z to the 3rd. That's my answer. I can't simplify it at all. Okay? All right. This is easy. Is the cube root of x times the cube root of x equal to x? That's going to be the cube root of what? What do I put inside right here, guys? X squared. Is the cube root of x equal to x? No, those are not equal to x. Okay, why not? I would say in order for a cube root to be equal to x, it must be the cubed root of x to the third power. I don't have 3, I only have 2, so that's not it. Okay, I know this is long, and I'm sorry. Oh, we're almost done. We're almost there. Okay, conjugate. 5 plus the square root of 3. The conjugate is this, guys. You write down exactly the same thing, 5 plus the square root of 3, but you take your eraser, you get rid of the middle sign, and you make it a negative. That's the conjugate. Okay, here we go with this problem right here. Example 5a. This is wrong. Look right here. Multiply top and bottom by the square root of 2. That's not right. The reason is the bottom is 2 terms. Everybody take your pencil right now, draw an arrow right there, and I want you to say 2 terms. If you have 2 separate terms, you have to multiply by 2 terms. And it's going to be the conjugate. So you're going to multiply by 1 minus the square root of 2, and you're going to do that to both the top and the bottom. 1 minus the square root of 2. On the top, one word that tells us how to do it, you distribute. So the square root of 5 times 1 is the square root of 5, minus the square root of 2, the square root of 5 times a negative square root of 2, that's a negative square root of 5 times 2 is 10. The bottom are conjugates, guys, so all I have to do is F and L. So all I do is 1 times 1 is 1, and then I go square root of 2 times a negative square root of 2. Positive times a negative is a negative. The square root of 2 times the square root of 2 is, everybody tell me, it is 2. Good. We're not done. So that's the square root of 5 minus the square root of 10 over 1 minus 2, that is a negative 1. Now, that answer is fine. It's just awkward. So this is acceptable, but you know what's better, you guys? Take that negative, pull it up to the front, and distribute it. So it's better to say negative square root of 5 plus the square root of 10. Those are exactly the same things. I just took the negative up and distributed. This guy is better than the other guy. Okay, let's do the next one. Question B. I have 2 terms, so I have to multiply by 2 terms. So this is 5 minus the square root of 2. Multiply the top. 4 square root of 3 times 5. On the outside, 4 times 5 is 20. On the inside, square root of 3. Now I'm going to go 4 square root of 3 times negative square root of 2. Positive times a negative is a negative. On the outside, you have a 4. On the inside, you have 3 times 2, which is 6. The bottom are conjugates. So you go first, 5 times 5 is 25. And then last, that's a square root of 2 times a negative square root of 2. Guys, a positive times a negative is a negative. What's the square root of 2 times the square root of 2, everybody? 2. So your answer is 20 square root of 3 minus 4 square root of 6 over 23, and that's my answer. Done. Who says, this is really long, but I still feel good? Let me see how you feel. Okay, we're almost done, guys. Just stick with me. I'm sorry this is long. I just have to get through so much material. This one's kind of tough, just so you know. The bottom is 2 terms. So I have to multiply by 2 terms. And it's the same. Some people do this. They make the bottom a negative and the top a positive. That's wrong. The signs have to be the same. So this is minus the square root of 2. Okay, add parentheses right there. On the top, you have to FOIL. I'm going to go slowly. 4 times 1 is 4. Outside is 4 times a negative square root of 2. That's negative 4 square root of 2. Inside, negative square root of 3 times 1. That's a negative square root of 3. Then last, negative square root of 3 times a negative 1. A negative times a negative, times a negative square root of 2. A negative times a negative is a positive. The square root of 3 times the square root of 2 is the square root of 6. You guys, look at what I've got right there. None of those can be added together. They all have different roots or have no root. So I can't do anything to this. On the bottom, I have F and L. So I go 1 times 1 is 1. Positive square root of 2 times negative square root of 2. Positive times a negative is a negative. Square root of 2 times the square root of 2 is 2. So that gives me 4 minus 4 square root of 2 minus the square root of 3 plus the square root of 6 all over negative 1. Is that acceptable? Tell me that. Full credit, yes or no? Full credit, but awkward. Is this right? Look, bring the negative up. A lot of people do this. Is that right? When you bring it up, what do you have to do? Change all the signs. So the 4 square root of 3 is a positive, the square root of 3 is a negative, and that square root of 6 right there is a negative. So we have to change all the signs. Either one of those is acceptable. The bottom one is better. Okay? All right. 6 and 7 and we're done. You guys see these little questions they ask you like that? They love them. They love them. They're going to ask you this all the time. Okay? Is this always true? The answer is no. The answer is false. It is not always true. You know why? And it's probably more than what you were ready for. What if A is a negative 2 and B is a negative 2? That would give you the square root of a negative 2 times the square root of a negative 2 equals the square root of negative 2 times negative 2. Well, negative 2 times negative 2 is a positive 4. Square root of 4 is 2, right-hand side. Look at the left-hand side. The square root of a negative 4 is I times the square root of 2. Square root of a negative 2 is I times the square root of 2. So the square root of 2 times the square root of 2 is 2. Does anybody remember what I times I is? Do you remember that? It is a negative 1, so that would give you that. I wouldn't worry about that much right now. We haven't even talked about imaginaries yet, okay? But that's why. Can the square root of C ever be a negative number? Square root of 5. Oh, let's go square root of 9. Square root of 9 is a 3. Square root of 25 is a 5. The square root of 36 is a 6. The square root of 81 is a 9. Can a square root ever give me a negative number? Tell me that. No. What if we did the square root of negative 9? That's not a negative answer. That's an imaginary. That's 3i. You know why it can't? So can it ever equal a negative number? No. You know why? In order to do that, guys, you'd have to have a negative sitting out there in front. If you had negative square root of 9, that would give you a negative 3. But if there's no negative sitting out in front of it, there is no way that that thing is going to be a negative. Okay? So I'm going to say the square root of C is a negative number if there is a negative, I'm going to say only if there is a negative in front of the square root. That's it. Long.